Welcome to the fourth session of Playing with Numbers. Today, we will be learning the highest common factor, which is commonly known as HCF. Let's start with factors. The numbers that divide a given number exactly are called its factors. Think of the number 12 and 18. We know the factors of 12 are 1, 2, 3, 4, 6 and 12. Whereas the factors of 18 are 1, 2, 3, 6, 9 and 18. As you see, some of the numbers here are given in red colors. Why is it so? Because those factors comes both for 12 and for 18. So such factors that are common to two or more numbers are said to be their common factors. So the common factor of 12 and 18 are 1, 2, 3 and 6. Let us practice with some questions. You can take your rough book and start doing it now. The first question, you have to find the common factor of 20 and 28. Question B, 15 and 25. Question C, 35 and 50. Question D, 56 and 120. Question E, 4, 8 and 12. And the last question F, 5, 15 and 25. Now let's have a check of the answers. For question A, the answer is 1, 2 and 4. Whereas for question B and question C, the common factors are 1 and 5. Question D, the common factors are 1, 2, 4 and 8. For the last question, question F, the common factors are 1 and 5. Now, in the first question, we have got few common factors. You remember those common factors? They were 1, 2, 3 and 6. Out of those common factor, which is the highest common factor? Of course, it is 6. So, we call 6 as the highest common factor. What is this highest common factor? The greatest factor of the given numbers common to the numbers is known as the highest common factor. Usually, we call it as HCF. It is also known as the greatest common divisor GCD. So for our first question, where we have done with the common factors of 12 and 18, we can say like this, the HCF of 12 and 18 equals 6. Let us see what is the procedure for getting HCF by prime factorization. In step 1, we express the given number as the product of their prime factors. Step 2, we choose the prime factors common to the given numbers. And in the last step, that is step 3, we find the product of these common factors, which is the required HCF. Let us find the HCF of 850 and 680 using prime factorization method. First, we go for the prime factorization of 850. and 680. 850 equals 2 into 5 into 5 into 17. 680 equals 2 into 2 into 2 into 5 into 17. The common factors for 850 and 680 are 2, 5 and 17. So to get the HCF of 850 and 680, we go for the product of 2, 5 and 17, which gets us the answer as 170. Yet another method of finding HCF, we call it as division method. We'll see that with the help of some examples. First number is 45 and 135. Let's try to get the HCF of 45 and 135. Both 45 and 135 is divisible by 3 and the quotients are 15 and 45 respectively. Again, when it is divided with 3, the quotients are 5 and 15. We divide it with 5. The quotients are 1 and 3. So that when you see there is no other number common to 1 and 3 other than 1. So we stopped it here. So HCF equals the product of 3 into 3 into 5 and gets us the answer 45. Let's take the case of 72 and 63. Both of them goes with the number 3. We divide with 3 and the respective quotients are 24 and 21. Again, both are divisible by 3. We get the quotient as 8 and 7. As you see, there is no number which is commonly divisible by 8 and 7. So we stop there and the respective HCF is the product of 3 and 3 and we get the answer as 9. Here comes the third question to find the HCF of 90 and 30. As before, when you do the calculation, we get the HCF as the product of 2 into 3 into 5. That gets the answer 30. One more question is dealt, that is 36 and 72. Here we do the division with 3. We get the quotient as 12 and 24. Dividing with 2 again gets the quotient as 6 and 12. Dividing with 2 gets the answer as 3 and 4. As you see, 3 and 4 has got no other common factor other than 1. So the required HCF is the product of 3 into 2 which gets us 12. So that here we got the HCF as 12. There is one more method of getting the HCF. This method, we call it as continued division method. Let us try with the example of finding the HCF of 30 and 42 by using continued division method. We divide 42 by 30, which gets the quotient as 1 and the remainder we got it as 12. You divide the previous divisor, that is 30, with 12 and again you get the quotient as 12 and the remainder 6. Dividing with the previous divisor 12, we get the quotient 2 and the remainder 0. We repeat the procedure till we get the remainder 0. Here, whatever is coming as the last part, that is circled 1. Here you can see it is 6 which is circled. That is taken as the HCF. So the HCF of 30 and 42 is 6. This method we call it as continued division method. Suppose we have three numbers for finding the HCF. Here also we can do the continued division method. Let us see with the help of an example. The question given is to find the HCF of 150, 375 and 210 by continued division method. We prefer to do this when there are three numbers or the given numbers are larger numbers. So here we divide 375 by 150. The quotient is 2 and the remainder is 75. We proceed again. We got the remainder 0. So once we get the remainder 0, we can stop it there. So that in the first part we got 75. But we didn't try with the third number. Continue with the third number. So 210 we divide with 75 and we got the quotient as 2. The remainder is 60. Again divide with 75 and we get the quotient 1 and the remainder 15. Divide with 60, we get the remainder as 0 and the quotient as 5, which means it's exactly divisible. So that in this case, the last one divisor is 15. So that is taken as the HCF. So today we learned the different methods of HCF. Practice these very well so that you will be able to do all the questions related to HCF. Before we conclude, let's have a quote by Walt Disney. All our dreams can become true if we have the courage to pursue them. Thank you, children. Have a nice day.